friends, welcome back to Rank Master series. I am Mahendra and today is the day to stop talking about theory and start building. Yes, in our previous video we covered what RAG is, how vector embeddings work and different types of vector databases. Today we are mixing all together and building our first fully functional RAG system. By the end of this video, you will have a complete RAG system that can ingest documents, create embeddings, store them in a vector database and answer user query on your own documents. The best part is I am keeping this code simple and beginner friendly. Okay, let's get started. Before starting the code, let's discuss what our system will do. The first step is document ingestion. We will be loading and reading our documents. Step 2 is text chunking. We will be dividing our documents into smaller parts or chunks. Third step is generating embeddings. We will be generating embeddings for the chunks using the sentence transformer models. And the fourth step is we will be saving the embeddings that were created to our vector databases. And the fifth step is we will be taking the user query and retrieving the k relevant chunks. And the final step will be sending the prompt plus k chunks to the LLM to generate the answer for the query. Okay, let's start the coding part. Open your VS Code and we'll be using Python with popular libraries like LangChain for the RAG framework and sentence transformers for creating embeddings and Groq for chart purpose. And I will be using ChromaDB for storing the embeddings. Don't worry if you have not used them before. I will be teaching everything as we go on. First, open your terminal. I have created a Conda environment for this tutorial. First, let's install the required libraries for creating our project. So create a requirements.txt file. First, we will be requiring python.env and the second is LangChain community and LangChain Groq, ChromaDB, Hugging Face Hub and finally sentence transformers to create this project. So let's save it and install all these libraries. Since I have already installed them, it was showing requirement already satisfied. You guys should install all these libraries before proceeding to the tutorial. Okay. Next, create the main file. I will be creating it as rag project.py. And to proceed with this project, you will be needing Groq API key. So I will be providing the link in the description to get the API key. When you click the link, this website will be opened. So after that, click create API key. It will ask for the name, enter a name and just submit. Your API key will be generated and copy the API key, come back to the VS Code and paste your API key in the .env file. And keep in mind, never commit this .env file to version control because API key should stay private. Okay, first let's handle document ingestion. For this example, I will be using simple document text files and after that you can change it to deal with PDFs, HTML files, Word documents and CSV files later. Okay, first let's import all the required libraries. Okay, we have imported all the required libraries. We will be using .env to load the Groq API key from the .env file, and from LangChain community.document loaders, we will be using text loader to load the text document files from the document directory. And next, we will be loading text splitter from LangChain for splitting the documents into smaller chunks. And to create the embeddings for the documents, we will be using embeddings module from LangChain community. And we will be using Chroma from vector stores for storing our embeddings in the vector database, chart Groq for creating the chart interface, and finally retrieval QA from langchain.chains. Okay, first we'll be creating the instance of .env to load the API key. Next, we shall define a function to load our documents. I will be creating it as load documents, and it will be taking the parameter of document path. This function is straightforward. It finds all the .txt files in the provided directory path, and it loads them using the LangChain's text loader. Each document becomes a document object with content and metadata. Let's create a sample document folder, and we will be creating 3 document files in .txt files for this project. So let's first create a folder. I will be naming it as documents. In that, we will be creating 3.txt files. Okay, next, for filling these text files, I will be using ChatGPT. I have asked it to create 3 text files for my RAG project. It has created 3 text files. The first text file is on climate change, next is machine learning, and the third one is on ancient Egypt. I will be copying this text and simply I am pasting it here. Okay, now we need to split these documents into smaller chunks. So for splitting of documents, I will be creating a function called chunk documents. Okay, let me explain these parameters. Chunk size equal to 1000, which means each chunk will be roughly 1000 characters. Chunk overlap is equal to 200, which means adjacent chunks will share 200 characters to maintain context. And finally, length function is equal to length. We are measuring length by characters count. The recursive character text splitter is smart because it tries to split the at natural boundaries like the paragraph and sentences, not just at arbitrary character counts. So this preserves meaning and context, right? You may ask me why you have taken only 1000 for the chunk size. It's for only good balance. Large enough to contain meaningful context and small enough to maintain the retrieval task. Okay, now comes the magic, converting our text into embeddings. These are the numerical representation that allows for the semantic search. So for that, I will be creating a function named create vector store. This function does several things at once. The first will be creating embeddings using Almini LM L6v2 model. And next we will be saving those embeddings in the ChromaDB. This persist directory means it saves everything in a ChromaDB folder so we don't lose our data. When I run this code in the directory, a ChromaDB folder will be created and all the embeddings will be saved there. The beautiful thing about Chroma is that it handles all the complex vector operations behind the scenes. Okay. We just need to give it documents and embeddings, and it figures out how to store and search them efficiently. One important note, creating embeddings cost money with OpenAI, but it was not too much and it is very affordable to create embeddings with OpenAI. Okay, now let's build the retrieval part of our RAG system. This is where we take the user's question and find the most relevant chunks from the database. For this purpose, I will be defining a function named retrieval QA Let me break down what's happening here. First, the LLM setup. We will be using Llama 3 8B8192. Groq model for our RAG system. And next, retrieval configuration. K is equal to 3 means we will retrieve 3 most relevant chunks from each query and we will return these so you can see what information influences your answer. Okay. The retriever works by converting your question into the embeddings, finding chunks with the most similar embeddings, returning the top matches with their similarity scores. Okay, now let's create our main function that will join everything together. So find main. Okay, this is the main function. It creates a simple interactive loop where you can ask questions about your documents. First, we should give the path of our document folder, and all documents will be sent to the chunk document function. So it will create the chunks, and the chunks were sent to the create vector store function. So chunks were converted into embeddings, and those embeddings were stored in the ChromaDB folder. So after running this code, you can see here a ChromaDB folder will be created. So let's run this. This might take a minute depending on how many documents you have. You can see here a ChromaDB folder has created and our embeddings were saved here. Now we can ask the questions related to the documents. So let's see. Yes. You can see here for the question, what industries benefit from machine learning applications? It has generated the answer, and you can see from which sources it has generated it. The system also shows the sources, so you can verify the information and understand how it arrived at the answer. Okay, now let's understand what happened when user asks a question. Basically, when you ask a question, the question is when you ask a question, the question is converted into embedding vector, and the system will search for the top 3 relevant documents based on the embedding vector created. So these 3 chunks were mixed with the question and it was sent to the LLM. The LLM will generate the answer for the query based on the chunks retrieved and the user question. The beauty of RAG is the transparency. You can always trace back to see exactly what information influences the answer, unlike a black box AI response. Coming to the enhancements, you can modify the code to support more file types like PDF, Word, CSV, and you can add metadata filtering. You, you should implement better chunking strategies. At present, I have used only overlapping chunking. There are other chunking strategies too, and you can add a web interface using Flask or Streamlit. I recommend Streamlit if you are not too good at front end because Streamlit is easy to create a web interface using Python. Next, for performance improvements, you can experiment with different embedding models. At present, I have used sentence transformer for creating the embeddings. You can use OpenAI also. Actually, I will be providing the OpenAI code also in the GitHub, so you guys can check it out. Check it. This is the code for the Groq. It will be available in the GitHub. And if we want to use OpenAI, the small modification you have to done is instead of Groq, here you should initialize the OpenAI embeddings and you should use chart OpenAI. You should make these two modifications to use OpenAI embeddings and to get answer from OpenAI. Okay. Coming to troubleshooting issues, if you are getting invalid API key, check that your Groq API key is correctly set in the .env file or not. Okay. Or if you are getting any other error, just go to the console.groq.com and revoke the key that you have already created and create a new key. If you are getting a error like Groq model not found, once check that you have written the Groq model name correctly or use any other models like Llama 3.170b or 3.18b or Mistral 8x7b. If you are getting a warning like no relevant documents found, try rephrasing your question or check if your documents actually contain that information. Like if you have uploaded a machine learning text file and you are asking about a cooking recipe, how can it answer? Okay. Coming to slow performance on embeddings, the Hugging Face models once download then runs locally. So subsequently runs will be much faster. The initial run will take some time, but after that it will be faster. Okay, I recommend you to build your own system as I said in this, explained in this tutorial, and try more documents, experiment with different embedding models, and enhance to take the other document files too. And all the code I have taught today and the code related to OpenAI will be available in the GitHub. I will be providing the GitHub link in the description. So don't hesitate to go to my GitHub and access those files. Okay, in our next video, we are diving deep into advanced chunking strategies. We will explore how to handle different document types, preserve important context, and optimize chunk sizes for better retrieval performance. If this video helped you build your first RAG system, please give it a thumbs up and subscribe for the complete RAG series. Your support helps me a lot to create more such videos. If you get stuck somewhere or you have questions about this tutorial, just comment it before or you can mail me. I will be providing my mail in the description. I try to respond to everyone. Thanks for coding along with me today. And I will see you in the next video where we will make the next RAG system which can handle different document types and different chunking strategies. We will be creating the Streamlit interface also. Okay, that's it. Bye, friends.